Last time we talked about Cartesian coordinate system and polar coordinate system, and we said if you have a Cartesian coordinate system, so in the first quadrant you will have the x component is positive and the y component is also positive, and in the second quadrant you will get a negative x component while the y component is going to be positive. In the third quadrant you'll have the two components, the x component and the y component are negative, while in the fourth quadrant you get a positive x component and a negative y component. And we also talked about addition of two vectors, and we said if you have the vector A and vector B, then the addition of them is also a vector, that's a vector C, and the vector C, it's simply you add the A plus B, and within that addition you add the x components together, that's ax plus bx along the I, along the x-axis. I is the unit vector, and then the ay plus by, those are the two y components for the a component and for the a vector and the b vector, and that's along the y-axis. And this is the addition of two vectors, and if you look at this, this will give you just a number, and this bracket will also give you just a number, and those will actually be translated into a c along the x, a component for the c vector along the x-axis, and a component for the c vector along the y-axis. And a good example for this is this example. If you look at this, we have three points, three positions, A, B, and C. Those are three vectors. A is 0, 2, and 1, and we read this 0, 2, and 1. That's 0x component, 2 y components, and 1 y z component. And it doesn't matter the units; it's in some units. So if we're talking about the addition of the three vectors, can you guess which one is the right answer? A, B, or C? So guys, you're saying B. Does anyone have any other solution? Do you think the solution can be something else, A or C? So you all agree. So simply we add 0, 3 plus 1, that's 4. 2 plus 0 plus minus 4, that's negative 2. And 1 plus 2 plus 2, that's 5. And this is the right answer. This is the addition of the three vectors. Can you guys calculate for me what is the magnitude of that vector? That vector? So you're saying it's going to be the square root of 4 squared plus negative 2 all squared plus 5 squared. If you add those squared together and under the square root, you should be able to find the magnitude of that vector. Can you find the angle that vector makes with the x-axis, y-axis, and the z-axis? And this is similar to the problem that we have in the assignment. And we talked about that problem last time. Right? 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 Right. Yes, ask.
I wasn't here in the last lecture, so how we get the angle.
If you can meet me after class, I will show it to you. I'll gladly show it to you. Okay? But not to waste the rest of the time for the rest. I will go on. Okay? Okay, so that's the answer, and we talked about unit vectors, and we talked about what does the unit vector notation mean, and we talked that we have three unit vector notation. It's I, J, and K, and we characterize them by a hat on top of them, and that hats mean those are unit vector notation. And unit vector notation means that the magnitude of those units I, J, and K is each one of them has a magnitude of 1, and they specify to us the direction of any vector. I means along the x-axis, J means it's along the y-axis, and K means that it's along the z-axis. And that's how we draw it. I, J, and K. So that was just a revision for what we have studied last time, and also talked about the mistake that we all do when we calculate the angle that any vector makes by just using the calculator. And we said that you can make a mistake in here if you just depend on the calculator without drawing or knowing in which quadrant is the vector located. You should look into this when you try to find the direction of any vector. So that was simply what we have studied last lecture. There is a good example in here, guys. I would love that you all solve it, or at least read it at home because it's very easy, it's very simple, and it's a real life problem that describes to you a problem that's from real life. Then this takes us to